Okay, so looking here at question 2, 2014. So firstly, what is the purpose of refluxing? Always refluxing is to allow time for reaction to complete without loss of solvent. Part 2, name the type of reaction that occurs during this stage. So we're making soap, so it is saponification, or if you want to state, base hydrolysis of an ester. Next then we're looking at what substance was removed by distillation in stage 1. So you're told at stage 1 the students refluxed, okay, and then the apparatus was then allowed to cool and rearranged for stage 2. So at our first distillation we end up with our solvent being removed, so that is ethanol. Then you're asked to explain the function of brine, okay, and soap is insoluble in the brine, so it precipitates the soap because soap is insoluble in the brine. Okay, next question then, why was it necessary to wash the soap thoroughly? Okay, and the reason why you do that is to remove any sodium hydroxide. Remember, in our refluxing stage, we mix sunflower oil, which is my ester, my sodium hydroxide and the ethanol together. So my filtration removes my ethanol, and then I have to wash the soap to remove any sodium hydroxide that could be present. How the students have washed the soap, and there's 2 ways that we do this. Again, you use the brine, or you could also use ice cold water. Now we'd have just used brine and that would have removed the sodium hydroxide. Remember, the sodium hydroxide will be soluble in the brine. Draw the structure or give the name of a co-product. So I'm making my soap, and you have to know the co-product here is glycerol, which is 1,2,3 propan triol. Okay, so propan is 3. Ols means there's OHs, and tri means there's 3 of them. So that is your structure and name of glycerol. And then where is that located? Again, this is soluble. If you look, all these OH means it's soluble in water. So that would be located in the brine. Next then, given that the sodium hydroxide is in excess, calculate the grams of soap. So that's stoichiometry. So again, that's done. So if you have any problems with that, let me know. So then suggest part G with reference to its structure, why or how we can use soap as can dissolve both the non-polar oils. So soap has a non-polar head, and this non-polar head dissolves non-polar substances like the oils, and then it has a polar tail, and that then can dissolve polar substances like salts. And just to show you the diagram, okay, all of this here, or up to that, okay, is all non-polar, okay, but the ending here, that's its polar part. So that will dissolve the polar substances, and this long carbon chain will dissolve the non-polar substances.